Welcome to our deep dive into the fascinating world of electrostatic induction. Ever rubbed a balloon on your head and watched your hair stand on end? That's electrostatic induction in action, folks. It's all about the invisible forces between charges and how they can rearrange themselves without even touching. Get ready to unlock the secrets of electrostatic induction. Imagine a neutral object like a metal sphere just hanging out, minding its own business. It's teeming with charges, positive ones and negative ones, all jumbled together in a perfectly balanced mix. But don't let that fool you, because things are about to get a whole lot more interesting when we introduce a charged object into the mix. Now let's bring a negatively charged object like a magic wand that's been rubbed with fur, close to our neutral metal sphere. Even though they aren't touching, the negatively charged wand creates an electric field that reaches out and interacts with the charges in our neutral sphere. This electric field is the key to electrostatic induction. The negatively charged wand repels the negative charges in the sphere, pushing them as far away as possible. Meanwhile, the positive charges in the sphere are drawn closer, like magnets with opposite poles attracting each other. This creates a separation of charges within the sphere, with positive charges gathering on one side and negative charges on the other. Thanks to this charge redistribution, our once neutral sphere now has two distinct regions of opposite charge. The side of the sphere closest to the negatively charged wand becomes more positive, as those positive charges are drawn closer. Meanwhile, the far side of the sphere becomes more negative, as those repelled negative charges bunch up, trying to get as far away from the wand as possible. Now, things get even more intriguing if we introduce a grounding wire to our setup. If the sphere is grounded while the negatively charged wand is still nearby, those negative charges on the far side of the sphere see their chance to escape. This leaves the sphere with an overall positive charge, since many of its negative charges have made a run for it. But what happens when we remove the charged wand? If we didn't ground the sphere, those separated charges will start to mingle again. However, if we did ground the sphere, it's a different story. Those negative charges that fled into the ground are gone for good, leaving the sphere with a net positive charge. This shows how electrostatic induction can have a lasting effect, even after the charged object is removed. And there you have it. A simple breakdown of electrostatic induction. We've seen how a charged object can rearrange the charges within a neutral object, creating regions of opposite charge and even inducing a temporary or permanent charge. Thanks for watching, and stay curious. Keep exploring the world around you, and never stop asking questions about the science that makes it all possible.